Hey, good morning. Let's do some geometry. Let's do some proving. The holiday weekend threw me for a loop this week, so you get your video on Thursday instead of Wednesday. This chapter, we're getting pretty good at proving things by this point. At least I'm hoping we are. I think everybody is. Um, so I wanted to just kind of go over a few different proofs with you all. Looking for some extra light. See if that helps. Whoa, doesn't help me. Okay, so I just chose the last two proofs in the section. What are we on? Lesson 3 of chapter 4. The second to last one, the flute proof. You're trying to prove that triangle LUE, that triangle FLE and triangle TUE are congruent to one another. That's what that little sign means, the equal sign with the squigglies. And always keep that in mind when you're doing it. Now, at this point, you have two different means of proving triangles congruent in your within your realm of knowledge. Okay, one of them is the side angle side postulate, and the other one is the angle side angle postulate. So we're going to have to use one of those to prove these two triangles congruent. And side angle side states that if two sides and the included angle of one triangle are equal to two sides and the included angle of another triangle, then the triangles must be congruent. Angle side angle just switches the words. It has to be two angles and an included side of one triangle, equal to the two angles and included side of the other. So let's see which one we're going to do here. Something to write with. All right, I'm back, and I'm bad. Okay, so let's see. We've got LUE. I'll use a different color to mark it up. The first step of our proof, obviously, you're going to start with triangle LUE is equilateral, the very first thing that we are given. Now we're given three pieces of information here. We're going to use them in three different steps. Okay, so LUE is equilateral, given. Now, what does that tell us? We're dealing with triangles FLE and TUE, by the way. So keep in mind those two triangles all the time. You're always trying to show things about those triangles. Now, the first thing, since it's equilateral, that means that FL has to be equal to UE, right? It's equal to this LU also, but we don't really care about that. Okay, so let's go ahead and say that, because that's two different sides of these two different triangles. So that's a good step. So I'm going to say that segment LE, I would just write LE is equal to EU because of the definition of equilateral. You can write out the definition if you like, but I don't think it's totally necessary. And I'll just do my shorthand here. Okay, 3. I think we've gained as much information as we can from the first set of given information. So let's do the second one. Angles 1 and 3 are supplements of angle 2. Given. Now, this should set off some alarms in your head. I'm hoping that you'll remember earlier, one of the things that we proved is that supplements of the same angle are equal. So these two are both supplements of angle 2. That means they must be equal. And that's because of the theorem that states that supplements of the same angle are equal. Beautiful. All right, so now we've got, let me go ahead and mark it up on here. We've got that angle 1 is equal to angle 3. Aha, we're getting somewhere. So now all that's remaining to do, if we think about it, we've got a side and an angle. So either we would love to show that this side is equal to this side, so FL is equal to UT, and that would give us side angle side, or we would love to show that this top angle is equal to this top angle. So that would give us angle, side, angle. Now, let's go ahead and move on to the next step and see what we're given. Aha! We are given that FL is equal to UT, so that does it. FL is equal to UT. So that's it. That's all we needed to know. We've got side, angle, side, and it's perfect. So we've proven it. We've shown that triangle FLE is congruent to triangle TUE because of side, angle, side. And that's it for our first proof. They're getting pretty fast now. I think I saw in class too that people are picking up a little bit, which is great. Okay, next one we're going to do, that marker doesn't work very well. I chose the viola proof, so let's see how that goes. All right, first thing we need to do, we draw the picture, given what we need to prove. I'm going to write the statements. Oh yeah, this one's better. Statements and reasons. Ding. All right, we got statements and reasons. What we are trying to show is that VIO is congruent to ALO. Now remember that it's written in a corresponding way, so that V corresponds to A, L corresponds to I, and obviously O corresponds to O, since it's the same thing. And we're given that O is the midpoint. Ooh, that gives me some information. That angle V is equal to angle A. That's our second piece of information. That's great. That gives us an angle. And we're also given that OI bisects VOL. Oh, and that OL bisects IOA. All right. All right, let's see what we can do. The first thing we know is that the first thing we're given is that O is the midpoint of the segment VA. Given. Step 2, I think we should use that information. Might as well. We're given that O is the midpoint of VA. A midpoint divides a segment into 2 equal parts. So I know that VO and OA are going to be equal. VO equals, I guess I should say AO there. VO equals AO. A midpoint of a line segment divides it into 2 equal segments. Now, mind you, my wording might not be perfect. Feel free to look up these theorems and definitions in your book. That's a really good idea. In my opinion, though, as long as you're familiar with it and understand the meaning behind them and can word them appropriately, then I'm okay with that. Like I said, every proof is going to be individual. A lot of proofs will be proven the same way by different people, but there are many, many ways to prove things true. And so it's your own proof. It's you doing the proving. Don't forget that. All right, number 3. All right, so all we have so far, we've got a side. We've got another side. So we've got these sides are equal. The next thing we know is that angle V equals, the measure of angle V equals the measure of angle A. Given. Let's go ahead and mark that on here. V equal to A. Now we would love to now either show that that side is equal to that side, or that this angle is equal to this angle. So let's see, which one are we going to do? This one involves angle measures, so that's probably where we're going to wind up. OI bisects VOL. All right, last given. OI bisects VOL. I'm going to go ahead and draw that on, well, actually, I'm not going to draw that information yet. We'll need another step before we can draw anything else. OI bisects VOL, and OL bisects IOA. Now, what was I about to point out? Okay. Notice that this set of given offers two pieces of information at the same time. That means you're going to use them in the same way. Okay, you're either going to use them combined or you're going to do the same thing to both of them. So let's see what we're going to do here. OI bisects VOL. That means that this angle, VOI, is equal to IOL, right? Because an angle that bisects, a ray that bisects an angle divides it into two equal angles. That's the definition of angle bisection. And we'll also do, let's see, VOI, the measure of VOI is equal to the measure of IOL. We're going to do the same thing with the other one, that OL bisects IOA. We can do these at the same time. Okay. OL bisects IOA. That means that angle IOL is equal to LOA. And once again, that's the definition of bisect. Definition of bisection. Okay. Now, let me go ahead and mark up here what we have. We know that VOI equals IOL, but we also know that IOL equals LOA. So that means we get to use the same marks. IOL, that means that this one must have the two tick marks also. So that looks great. Now we see it in the picture, but we need to point out in the step that shows that VOI equals AOL. I did it LOA on here. I'm going to switch it around to AOL so that it keeps the corresponding parts. Okay, so we know, let's see, I'm going to change it over here. This is why you use pencil instead of Sharpie. Okay, whoa, let there be light. Okay, so angle VOI, the measure of angle VOI is equal to the measure of angle AOL. Now, what's the reason for that? We've got it here. How about substitution? You could also use transitive property in this case. Either one would be perfectly fine. Once again, it's your proof. Do it your way. Okay, as long as you do it, as long as you get to the end point. Okay, so now we've got it. We've got this angle and that angle, this side and this side, and that angle and that angle. We've got it. We've got ASA. So we've proven it. And thank goodness I didn't run out of room. Triangle VIO must be congruent to triangle ALO because of ASA. And there's teeny bit of room for this cutie. Perfect. Okay. So there you have it. Those are the two proofs I'm going to walk you through today. There's only one quick reminder. Let's try this one. Here's a flashback. If two angles are vertical angles, and I drew some nice little, on this side, I drew some vertical angles for you over here. Anytime you have two lines come together and meet at this vertex here, it forms vertical angles across from one another, diagonal to one another. So if two angles are vertical angles, then they are equal. That's it. That wraps up the program for today. Sorry to be a day late. I'll see you in class tomorrow. Please send me any questions that you have. I'm not going to assign any new homework for this time. Okay?